Let's take a quick look at algebra, and in this demonstration we are going to look at the language of algebra, collecting like terms, expanding, factorising and substitution. But first let's look at the why of algebra. Now, what is algebra? Well, it's a field of mathematics where we start to use letters, pronumerals, when we have an unknown quantity in order to help us solve problems. And solving problems is what maths is all about. Now, a simple way to look at this is to think of an example where you may have some amount of money. Now, you might have seen a box like this previously. Some amount, a number, goes into this box, and so some amount of money, you give away $20 and you're left with 10. So pronumerals or letters, okay, is simply going to take over this function of this box. Okay, it's going to hold some value, some unknown number as yet, but so we could rewrite this as x minus 20 equals 10. Now, when we get into another video of looking at equations, we can talk about this in more detail, but you can solve this equation now and you are left with x equals 30. Okay, so algebra helps us solve these type of problems. Now, here, this is a simple one, but you can get much more complex problems. The other handy thing about algebra is that it allows us to define the relationship that exists between different variables. Well, what is a variable? Well, let's have a look at a graph. It can be anything really. Variables, okay, and how they interact with each other is of great interest, whether it's medicine and how it interacts on people's health, or foods and how they interact on people's health. Here's just have a look at two variables, distance and time. Okay, you may be traveling on the highway and at a constant speed, and this graph in some way represents the relationship that exists between that journey, your distance you've traveled, and the time that you've taken to get there. Now, we can also explain this relationship as a rule or as an equation. So if we have distance equals speed and time, unless you're doing Einstein type work, this relationship holds true, and it doesn't matter what numbers you put in there. We can have a look at well, that's a simple linear relationship between these different variables. You can get more complex ones, such as when you drop a ball from a building, it doesn't just go at a constant speed. It accelerates due to gravity, and it follows a known rule since Newton. So distance travelled is, now this is approximate, 5t squared. Okay, that's a rule. Now, if you want to find out how long it takes for your soccer ball to drop off a 5-story building, well, you can figure that out, because we do know the laws of physics, and we can substitute well, how high that building is, and then you can solve for the time it would take. Or conversely, you could, given an amount of time, figure out how far your soccer ball falls. So this is great if we can represent relationships as equations and solve them. Now, the thing is, it's not always simple, these relationships. Often they're quite complex, and the major skill in algebra is that we need to simplify our understanding, or simplify these the relationships that exist so that we can solve it. So often we are going from the complex to the simple so that we can solve. So whether you're talking about fractions which you have to simplify, okay, that helps us in the end solve our problem. Whether you have to expand brackets, whether you have to factorize, or there's a whole host of simplification techniques, and we're going to talk about them, some of them right now, and that'll help us solve our problems. Let's take a look at an equation so we can understand the different parts of it. This is an equation because it contains an equal sign. An equal sign is very important because it tells us that one side is equal in value to the other side. It's balanced. Okay, we use this knowledge to help us solve problems later on. Let's look up at one side of this equation. Well, that's an expression. Okay, now an expression can be made up of one term. There's an expression on this side, or it can be made up of many terms. What is a term? Well, that is this and this and this and this. They're all separated by addition or subtraction. Now, you'll notice this term here is different to this term. This is called a constant term, and the reason is because it's always 3. It's never going to change. This is variable because it depends on what the value of x is. Now, x is what we would call a pronumeral. We treat it like a number. It is a number in every sense, so we can multiply it, divide it, and do all the operations we do with normal numbers, except we just don't know what it is at this point. Okay, so what are the pronumerals here? We would say x is a pronumeral. We say that y is a pronumeral. And we can say that, well, this is different, okay, because it's x squared. We are going to treat x squared differently to x, the same way that you would treat meters differently to square meters. Okay, you wouldn't compare meters in length to an area of square meters. Okay, so we treat x squared as not like to x. Now, a coefficient is another term you'll come across. What is a coefficient? Well, a coefficient is the number that's in front of the pronumeral. So let's take a look here. There's a coefficient of 4. Okay, now what's the coefficient here? Well, because it's a fraction, okay, we can say that y, it's the same as saying a half times y here. Okay, so the coefficient is a half. Okay, we'll say that this is 4 times x, so the coefficient is 4. Now what's a coefficient here? Well, there is no number here. Now you'll find if you have no number in front of the pronumeral, we treat that as a 1. Okay, so you could write here 1, and that does look like a half now, and you could write 1 there. Okay, so that all means the same, but the convention is we do not write the 1 in, we leave it out. So that's the same as negative 1 times x, so the coefficient here is negative 1, and in this case this is just a 1 here. Right, so let's take a look at what like terms are. Well, like terms contain the same pronumeral part. So what's x is like to, we'll say 2x or minus 3x. Any term that has its only pronumeral as an x. Y is like to, okay, it doesn't matter if it's negative y or if it's 100y, they're still like terms. Now what about xy? We start to join pronumerals together. So they're joined by multiplication here. Now this is when you see numbers joined together like this, that means that there's a multiplication in there. Okay, and likewise there's a multiplication here. We don't write it now because we're making that statement when you put them together. We're assuming they're multiplied. It says that they're multiplied together. Now is like to, well, it could be 2xy. Let's have a look at if this was 4yx. These would still be like terms. But the convention in this case is that when we would rewrite this, you would rewrite it in alphabetical order. So the right way to write a term like this is to have it in alphabetical order, xy. Now, if it's in expanded form, that's still like 8 times x times y would still be like to this. X squared is like to, well, again, minus 2x squared. I think you're getting the picture here, of course. We'll just make sure we cover our bases. If you expand it, it doesn't matter. As long as it's, now, just it is not, okay, like to x or 2x. Some common mistakes people make. You might also have x y squared is like to, well, as long as you've got x y y, okay, that's the same as squaring. It is not like to something with a y squared in it. Okay, you might have a z y squared. Okay, just because it's got a y squared does not make those two terms like. Here we can simplify this. Now, a common mistake is that people will look at the x and they say, oh, here's 1x, here's 2x. Let's put that together and say that's 3x. Now that's not true, because what we've got to account for is this little negative sign here. Now a good way to think of it is that negative sign is glued to the x. They are partnered together. You cannot pull them apart. So you can, if you want to, when you're starting off, circle or group like terms like this. Okay, so 2x minus x, and what's left over, just remember to include that sign, plus 4 plus 5. We're left with, that's a 1, remember, okay? I'll just write it in because we don't want to forget. 2x minus 1x is x plus 9. Okay, so this expression here is equivalent to this expression here. This is obviously a lot simpler way of writing it. Sometimes we need to expand. Now, and then we can collect like terms. Plus 3 minus x plus 2. Let's take a look at this. Now, if you remember the rules of expansion, it's saying, well, the distributive law tells us that there's another way of writing this. Okay, when you expand brackets, you have to multiply what's outside the bracket by every term inside the bracket. Sometimes you see this type of working out just to show that there's in this expansion we are multiplying. So we have the 2 times the x gives us 2x, and 2 times the 3 gives us 6. Minus 4 times the x equals minus 4x, and minus 4 times the 2 is minus 8. Now we have expanded our parentheses, our grouping symbols. We can identify which ones are like. Now here we can circle that and that. Now we are subtracting a larger number, so we're going to go negative here, negative 2x, negative 2. This is plus 6, take away 8. Right, let's take a look at multiplying and dividing terms. So let's start by multiplying. We can have 4x times 3y. When we're looking at this, you want to multiply the number part, the coefficients together, and then the pronumerals. So we can rewrite this as 4 times 3, because remember, order doesn't matter when we're multiplying, times y. Okay, 4 times 3 is 12, and we would write this as xy. Now that is just a simplified expression of what we had to start with. Okay, let's have a look at another one. Now sometimes you get negative numbers. Y. Now let's do the same thing here. Now it's a good habit to get into in writing it out in factor form, because you want to avoid silly mistakes where they make up a large amount of your mistakes as a percentage. So if you can eliminate them, you are going to notice a difference. So minus 5 times 12 times x times y times y. So a negative times a positive is a negative, minus 60 x, and then y times y here, we've got x squared. Now let's have a look at a division. So if you're given a division like this, a good way to work with it is to write it as a fraction. And factor it out. Okay, by that I mean break it up into its factors. Now you can write it as you don't have to go right down to prime factors, but breaking it up into useful factors. What do I mean by that? Well, here we can see that these 4's cancel. Now what do I mean by cancel? It's not 0. What's happening here is we're having a division. 4 over 4 equals 1. Okay, so this is going to be what this part, if that equals 1 times the rest of this doesn't change anything. Okay, so in this sense it's easy for us to cancel, and it leaves everything else as it is. Okay, so let's write it now. You've got to make sure you get everything. So 4 and 4 cancel. Check what else cancels. If there's a letter common at the top, remember we're treating pronumerals just like we do numbers. So if there's one factor at the top and another at the bottom, cancel that out as well. Now, while I'm talking about this, I suppose what you cannot do, okay, is if you have x plus 1 at the top and x at the bottom, you cannot cancel that. Okay, because we'll talk more about this later, is that you're treating that as one term, okay, and you're not going to break that up. Okay, however, if you had an x out the front of that, for instance, sum x multiplied by x plus 1, well, that we can cancel now. Okay, that's allowed, but not inside brackets, inside grouping symbol. Well, what do we do here? Again, I would factor it out. Okay, so 1 times, now when we got a negative, it's if you put it out with a -1, you'll see what I mean. So it's times 3 times 6 times, here we have, so if they're not too big, you can, these indices, you can write them out, y times y all over minus 1 times 6 times x times y times y times y. Now again, I would invest in this little process here of factoring it out because it's very easy to make mistakes. So this allows us to do our simplification process a lot easier. So let's have a look. Are there any common factors? Well, the negatives cancel out. So if you put them out like this, you know that the negatives cancel too, and leaving the rest positive. 6 and 6, x and x, there's no more x's now, but there are 2 y's at the top. Now in this process here, just be clear not to miss anything. Often people do the right working out to this stage, and then in the rush to write their answer down, they leave a y out at the bottom, or they miss something that should have been there. So 3x by x is x squared over y. Let's take a look at factorising then. We'll start off by factorising a simple expression. 4x plus 2. Well, when we're factorising, what I like to do is to break the numbers up into factor form, and it seems a little bit excessive at first, but there's a good reason. So 4 I can break up into 2 factors of 2 and an x, and 2 I can break up into 1 times 2. Now when we are factorising, we are taking the highest common factor and putting it outside the grouping symbol. So what is the highest common factor between these two terms? It's a 2, and then we put our grouping symbols in, and what's left over? So if we take that out, what's left? Well, it's a 1 and a 2. 1 times 2 is 2, times x is x. Now the reason I've put this 1 here is because in this case we've taken out the highest common factor, and it doesn't leave nothing. There is something left behind, and that's a factor of 1. Okay, so if we write it like this, we're not going to forget about this 1. Let's just have a look at another expression and we'll factorise this. Again, what we're going to do here is to write it out in factor form. So 1 times 2 times 7 times x, subtract 1 times 3 times 7 times x. Now we're looking for the highest common factor, which is a 7. And when we have, you have to also make sure you check any letters, because, or pronumerals here, because if you've got common letters, they too need to be taken out. So 7x goes at the front, and then we have what's left over, 1 times 2 times x, this is 2x, and minus 1 times 3, which is -3. Now, a good habit to get into is to test your answer here to check if you you can expand this to test if you get the question you started with. Now, when you are testing, don't just go down the page, do it elsewhere. So because we're looking for the answer here, we don't want to find the question we started with. Okay, so you start with what you got. Okay, and we are going to expand this. Okay, I'll write it out. 7x times 2x, that's that part, plus, and then the next part, 7x times -3. Let's have a look. So 7, you do the coefficients here, that's 14, and the x's, x squared, and the coefficients here, well, -3 times 7 is -21, and x left there. And you can see that this answer here is what we started with, so you can go ahead and give yourself a tick for that, because that answer is correct. Let's take a look at substitution. Now here we have an expression. Now the value of this expression depends entirely on what x and y, what their value is. Now that's why you get asked to evaluate an expression, what its worth is, how much it comes to, but you'll be told x and y values, so, and I say that we plug in these numbers, meaning simply that we take the number here and put it into the pronumeral in its place. So let's have a look. Now what you can do is, for cases like this where it's just a pronumeral by itself, that's fine. Just instead of the y, you can just put the 3. And here, however, there's a little habit that you might want to get into, is using parentheses to show the substitution. So we have -2x, so -2, and instead of x we are going to put parentheses, and in place of x we're going to have the -2. Now the good thing about doing this is that we take care of this multiplication properly. We are saying that it's this number here multiplied by this number here, so our directed numbers get looked after. So -2 multiplied by -2 is +4, which equals 7. So with these same values, let's try another one. Again, let's use parentheses here, because this index, we want to make sure we look after the -2 properly. Now this is a common mistake, and instead of the y, let's put parentheses. If in doubt, you can use parentheses. Okay, now why is this a common mistake? Because if you look at your calculator and you put in let's turn it on first, -2 squared. So here on your calculator we can see that most people write in this operation like this, and what happens is you get -4. Now that's wrong. Okay, now the reason is that people haven't put in the parentheses. So when you use your calculator properly, you do get the +4. Now why is it +4? Because -2 multiplied by -2 equals +4. Okay, so that becomes a 4, and this we're saying -1 multiplied by 3 is a -3. So by using these parentheses and substitution, it'll go a long way in reducing your silly mistakes. So that's the basics of algebra. So use these techniques you've learned to help you simplify so that you can end up solving some problems.